All right, so at this point in the lesson, we've talked about factors, we've talked about common factors, and we've done an activity on basically the candy tax, okay, which helps us make the greatest common factor more concrete. And what we want to do now is take that activity and apply it to algebra, which the activity slides we're guiding you in that direction. So the question we have here is, how do we apply this activity to algebra? Because it's fun to play around with candy and it's fun to work in our groups and stuff. At least I think it's fun for you guys. It's more fun than listening to me. But it's not going to do us any good if we don't connect it to algebra. So what I have in the notes, I have 3 examples of going through like GCF factoring, and then we're going to look at some special cases. So the first example is this one. So you have 4x squared minus 2x to the third. So when I do this activity with actual physical bags of candy, the first thing that my students do is they dump the candy out. They dump it out in the bag and they look at it on their desk, and they might sort it into piles. Basically, they want to take a good close look at whatever the candy was in the bag. The way I bring this into the activity is that's like doing the factorization, the prime factorization. So I'm going to do a little color code thing here. And I'm going to actually take out that minus sign. I'm going to change it to orange. And I'm only doing that to create a little bit more physical separation between the two what are called terms. So terms are things that are added and subtracted. So I'm going to factor the 4 into 2 times 2 and factor the x squared into x times x. And that's why I want to just bring down the minus sign in a different color, because I think it helps you see it a little bit better. Now the prime factorization on the next one is going to be 2, and then x to the third is x times x times x. So think of this as looking at those desks in the activity with all the candy spread out. So you have 2 Tootsie Rolls and 2 gummy bears, and this person has 1 Tootsie Roll and 3 gummy bears. Now what we want to look for is, what do they have in common? Because the rules for the candy tax are that you have to take the same thing from everybody. So even though this guy has 2 Tootsie Rolls, I can't take 2 Tootsie Rolls because this guy cannot donate 2 Tootsie Rolls. Okay, this guy has 3 gummy bears, but I can't take 3 gummy bears because this guy doesn't have 3. And so we want to figure out, what do they have in common? Well, they have a 2 in common, and they have 2 x's in common. This is my tax. The tax is a 2 and 2 x's. So I'm going to bring that outside. I'm going to tax that. And what I did was I multiplied the x squared. Okay, so that's where I got the x squared from. X times x was x squared. Now I want to see what's left. This is like thinking what's left on the desk after I take the tax out. So this guy had 2 2's and 2 x's, but I took out a 2 and I took out 2 x's, so he's just left with the 2. And then over here, we're just left with the x. And that's our factorization. Now, students will often say, but what happened to the other 2 and the 2x? It's accounted for out here, because remember, this is going to get distributed, and when you distribute it, then you're going to get it twice, because you're going to distribute it here and distribute it here. So we want to make sure we bring that back to the distribution. That's why you don't have to write it twice, because when you bring it out of the parentheses, like when you distribute it back, that's when you're going to get it. And that's how you would factor out the GCF. So if the direction said to factor that, that's how you would do it. Second example is this one. It is 6x to the fourth y squared plus 2x squared y to the third. And so you might freak out a little bit, like, wait a minute, we've got x's and we have y's. That's too much. You're going crazy, Miss Taylor. Stop. And what is this to the fourth? It's too much. It's not too much, because math is consistent. And so whatever the principle is, it's going to work for all of them. So we're going to break this into the prime factorization. 6 factors into 2 times 3. x to the fourth means x times x times x times x, and y squared means y times y. I'm going to bring down the plus sign. I'm going to hold the plus sign in a different color because that just creates a little separation instead of having like a big long thing of red there. 2 doesn't factor. X squared factors into x times x, and then y to the third will be y times y times y. So again, that's that prime factorization. It's like dumping out the candy bag. Just boom, like what do I have in here? Now we'll look for what do they have in common. They have a 2 in common. They have a couple of x's. We have 2 x's and 2 x's. That looks good. And then they have some y's. I have 2 y's and I can snag 2 y's over here. And that's all I've got in common. So the greatest common factor is going to be like all of that put together. Okay, it's going to be 2 and then an x squared and then a y squared. 2x times x is x squared. Again, if you're wondering where did I get that from, got it from right here. And then y times y is y squared. And then we need to say, okay, what's left? So Miss Taylor comes around and I take out that tax. I take that tax from you. What's left after that tax is gone? Well, there's a 3, and then we have x times x, which is x squared. Bring down that plus sign. And then over here, I have just the y. And that's all there is to it. Now, here's where we want to move with it. I don't actually want you to have to dump out the candy bag, okay? You can do this by listing out the prime factors. And basically, I want you to do it as long as you need to do it in order to get comfortable with it. But I eventually want you to stop doing it. Let's look at that third example. I got a couple more examples. This is 4x squared plus 2x plus 6. So this one's different. This is called a trinomial. The prefix tri means 3, and it's named that because there are 3 terms. You have a 4x squared, you have a 2x, and you have a 6. This would be like having 3 desks or 3 students. And but it works the same. Okay, in the activity you did, you had 4 desks. You had like 4 students, or maybe you had to make up some students. So let's go ahead and factor it because math is consistent. So once you know the principle, you're able to do all of it. 4 will factor into 2 times 2. X squared factors into x times x. I'm going to bring down that plus sign. This actually doesn't factor at all. Like 2x is 2x. So you can go ahead and split them up if you want with a times sign in between. And then 6 factors into 2 times 3. Now remember, in order to tax it, you have to be able to take it from everybody. Like everybody. So you can look at this and say, oh, they have an x and they have an x. I'm going to take out an x. You can't take out an x because this guy down here doesn't have an x. Okay, and so remember, with the candy tax, you have to tax the same thing from everybody. So I have a 2, I have a 2, and I have a 2, and that's all I can take. Because this guy has a 3 and nothing else. No 3, no 3. Yes, it's true that these guys share x's, but there's no x down here. And so we're going to tax out the 2 and then see what's left. So here I have 2 times x, which is 2x squared. Here in the middle, I'm left with just an x. And then here down here at the end, I am left with a 3. Now, just to get a handle on some of the vocabulary, what we would say happened here, okay, if you were asked to describe it, we would say we factored out a 2 or the 2. Okay, we would say we factored it out. Now you can say, well, what happened to the other 2's? They're there. They're just going to be there in the distribution. So when you distribute, you'll get the 4, and then you'll get the 2x, and then you'll get the 6, 2 times 3. So they're still there. Now, again, I mentioned what I want you to do eventually is to not have to do that prime factorization. And so a problem like this is the goal, this is what we're aiming for, is that you would look at this and you would say they both have a 3. I'm going to factor out a 3. You'd say this guy has 4 x's, this guy has 2 x's, so I can take out 2 of them. And then you'd look at this and you'd say, okay, we have 2 y's here, y times y, and we have 3 y's here, y times y, which means I can tax out 2 of them. Here, you had a 3, you took it out. You had 4 x's, but you took out 2, which means there are 2 left. And we had y squared, and we took it out, so that's not there anymore. Here, I had a 3, but I took it out. I had 2 x's, or the x squared, but I took it out. I have 3 y's, 2 of them got taken out, meaning 1 of them is left. And so ideally, what I want you to be able to do is to go straight from here to here without this step of expanding out, or what we call like dumping out the candy bag. Like, we don't really want to have to look at all that. But take your time. Do the prime factorization as long as you need to until you're comfortable. And that's different for everybody. And it's okay. Like, there's not a set timeline for when you have to get comfortable with something. I just want you to know, like, that's where we want to move. Now, the last problem in the candy tax kind of tackled a more abstract question. So let's take a look at this one. Okay, consider this. If you had 4x plus 4. So I hope that you would all recognize that the common factor is 4 and you're going to take it out. So if you have 4x and you take out the 4, you'll be left with the x. Here's the question here. If you have a 4 and you factor it out, what are you left with? Now, let's explore this a little bit, because there's 2 answers that students will often give. One of them is the correct answer and the other one is incorrect. So I'm going to explore the incorrect answer first and just show you why it's wrong and what you can do about it. The first incorrect answer that students will give is 0. And the reason they do that is they're probably thinking about the candy tax, and they're thinking, okay, if I tax out everything, which I think the last example you did, one poor person got all their candy taken away, you're left with nothing. So that would be a logical conclusion. So if you were thinking that, it's not that it's illogical. It is logical. It's just not right. And now we need to go and explore, why. Why isn't it right? So remember that the way you check your factoring, or the opposite of factoring, is multiplication. It's distribution. So if you took this and distributed it through, okay, you would get 4x. But what's 4 times 0? It's 0. And then what I want you to notice is that it doesn't match. Okay? If you think back to the last lesson, when you multiply it through, it should match. And it was supposed to be 4x plus 4, and we got 4x plus 0. So 0 isn't the right number to have there. But now that raises the question, what is the right number to have there, and how does that make sense? So watch what I do here. I'm going to do that prime factorization. I'm going to do something that we don't usually do with the factoring, okay? I'm going to do 4 times x, and instead of doing this as 2 times 2, I'm going to write it as 4 times 1. Would you agree that 4 could factor into 4 times 1? I mean, it seems kind of silly, and it's definitely not prime factorization, but when I do that, now I can see that the common factor is a 4, which we already knew. Now when I look and try to see what's left, I can see that I should be left with a 1. Now let's go check that. Let's just do a quick little check. 4 times x plus 1. So let's go ahead and distribute. 4 times x is 4x, and 4 times 1 is 4, and now they match, so I know I've done it right. So that's like just a little important piece. When you factor out everything, when you factor out the entire term, you are left with a 1, not a 0. So while I understand the 0 and I know where people get the 0 from, and it's not illogical, okay? It's not illogical at all to get the 0. It's just incorrect, and we need to remember this. So you need to go back to this idea and why you need to reason it through that way. Be patient with yourself. You might get it wrong a few times, and you got to go back and like rehearse it and remember this, and we need to review it a few times. Eventually it'll stick. Like, it does make sense that it should be a 1. All right, last little expression or example here, and this is just to introduce something that comes up later, okay? And we are going to do it later. So suppose you saw this. And it's probably going to freak people out, but what would the common factor be there? And so I'm going to pause the video in class for a little bit for you guys to kind of think about it. All right. So hopefully you've thought about it and you kind of have an idea in your head as to what you think the answer would be. So what we need to do is we need to look at the factors, okay? So I'm going to do a couple things here. The first thing I'm going to do is I'm going to change up the color on the operator in the middle. And again, that's like, I didn't do anything algebraically. This is a visual so that you can see it differently. So I have this expression over here and this expression over here. Okay, and now you can just see them separated a little bit better. The factors of this expression over here are the x and the x plus 2. And I know that's like weird to think of, like, wait a minute, the x plus 2 is a factor, but it is. So this is x times x plus 2. Those are the two things that are being multiplied. Over here, you have two things being multiplied. You have a 4 and an x plus 2. So now the question is, what do they have in common? Well, we can see they have the x plus 2 in common. I'm going to do one more thing where I'm basically going to change the color of the common factor so that you can see it. Again, no algebra being done at all. If you look at like these 3 lines, I haven't done any algebra. It's just been like thinking and learning how to see it the right way. The common factor, the GCF, is x plus 2. So here's what I'm going to do. Math is consistent. When we have a common factor, whatever the common factor is, we take it and we bring it out front, and then we put parentheses around whatever is left. I'm going to take the common factor and I'm going to bring it up front, okay? And then I'm going to put parentheses around whatever is left. So if I have x times x plus 2 and I take out the x plus 2, I'm left with the x. And if I have 4 times x plus 2 and I take out the x plus 2, I'm left with 4. This is actually a multiplication of 2 binomials, and this is, it gets into an idea called factoring by grouping. I'm not going to ask you to do this right away, but I am going to have you guys do it later when we're doing polynomials. So I want to introduce it now so that you can recognize it when you see it later, because this is essentially what we're doing. So that wraps up our lesson on greatest common factor, and I believe there's like a whole chunk of worksheet for you to do on this, and we're going to pick it up with the next adventure in factoring next lesson.